What's up, guys? It is Monday, May 18th. Today we are going to begin chapter 9, which is our last chapter of the year. All right, and it's going to start off with talking about scatterplots. Should be a pretty simple lesson. All right, let's take a look at our learning target right away. There's two of them today. So what we're going to be doing is first we should be able to interpret specific points from scatterplots. And second, we should be able to identify trends, gaps, clusters, and outliers. All right, so let's read quickly. Here, our key idea, a scatter plot is a graph that shows the relationship between two data sets. The two sets of data are graphed as ordered pairs in a coordinate plane. All right, so let's take a look at the first example, which is interpreting a scatter plot. So it's going to ask us specific questions about some of the points on the scatter plot. All right, so it says here, the scatter plot at the left shows the amounts of fat in grams and the numbers of calories in 12 restaurant sandwiches. How many calories are in the sandwich that contains 17 grams of fat? Okay, so I'm going to look at my X and Y coordinates and just see what they kind of represent. So my X coordinate represents fat in grams and Y represents calories. They're asking us how many calories are in a sandwich that contains 17 grams of fat. I'm going to identify the point, which is about right here on my X value, that has 17 grams of fat, and see how many calories does that have. If I look at my y-axis, okay, and I see about 400 here. All right, so if we read, it says we could do this also. We could draw a horizontal line from the point that has an x value of 17 and see where it crosses the y-axis, which is at 400. So that means the sandwich has 400 calories, and they show the picture here. Okay, now we're kind of going backwards. How many grams of fat are in the sandwich that contains 600 calories? So now I'm going to go back and I'm going to look at, here's 600 calories on my y. I'm moving over until I meet a point and I'm seeing what is my x value there. Okay, that would be about 30 grams, it looks like. So now it says draw a vertical line from the point that has a y value of 600. It crosses the x-axis at 30. So the sandwich has 30 grams of fat. So they show that here. All right. C. What tends to happen to the number of calories as the number of grams of fat increases? Pretty basic if we think about it for in real life terms. The number of grams of fat that increases the number of calories as well, is basically what this is saying. As the number of grams of fat increases, so does the calories of the sandwich. Kind of makes sense if you think about it in real life terms, right? All right, let's look at an extra example, and I can walk you through my thought process here. So they're saying, use the scatter plot from example 1. How many grams of fat are in the sandwich that contains 740 calories? All right, so let's look at 740 calories back in example 1. 740 calories would be around here, right? So how many grams of fat would there be? I would probably say that would range probably around 42 grams of fat, right? If we look at that and draw a vertical line to that point, right? Let's look at the other question quick. It's also asking us how many calories are in the sandwich that contains 33 grams of fat. So let's find the 33 mark on the x-axis and go up from there. All right, so 33 grams of fat is around here, right? How many calories would that be? Probably around like 640 or 645, right? So again, first learning target is being able to kind of interpret the points on a scatter plot, all right, which is what we just looked at. Example 2 now. Actually, before we look at that, let's read something quick. Okay, let's read something quick and look at some diagrams here. It also says here, a scatter plot can show that a relationship exists between two data sets. All right, so even though it's a scatter plot and it's not perfectly linear, it could show that there's a representation or a relationship that exists between the two data sets. Okay, so here we go. If something looks like this, a scatter plot looks like it's rising as we go left to right, that would show a positive linear relationship. The points lie close to a line, As x increases, y increases is what this is saying for this picture. That could show a negative linear relationship. As the points lie close to a line, as x increases, y decreases. It could show maybe a curved relationship or a nonlinear relationship where the points lie in a shape of a curve. And then it could be completely random. Okay, a scatter plot could be completely random where the dots are basically everywhere and it just shows no pattern. Okay, the points show no pattern. So example 2 is now identifying relationships. Let's look at that to meet our second learning target. Okay, so describe the relationship between the data. That means, is there a positive relationship, a negative relationship, a non-linear relationship, or is there no relationship, just like we looked at? Okay, so let's look at that first. Describe the relationship between the data. In this case, it looks like there's sort of a positive relationship, right? It's sort of trending as x increases, y increases. Okay. Now it says to identify any outliers, gaps, or clusters. So an outlier is essentially a point that doesn't match with the rest of the data. So I would say that this point right here, which is kind of, off the map from this linear, or what looks to be a linear relationship, that's a little bit off. That would be an outlier. Okay. Now a gap in the data would look something like this. See this area where it splits between the point of, it looks like about 32 or 33, 500 to this point of 40, 1500. There's a gap there where there's no data. So I'd identify that area as a gap. And then a cluster would be an area where there's a lot of data points. So I would call this a cluster. So let's see what the book says. It says the points appear to lie close to a line. Okay, so these points here look sort of like a line. So as x increases, y increases. So the scatter plot shows a positive linear relationship. That's the first part we talked about. Now they're identifying there's an outlier at 70 and 2250, which is this point that we talked about earlier. Okay. There's a cluster of data under the $500. All right, so under the $500, this area we talked about it is a cluster, and there's a gap in the data from 500 to 1500. So again, from here to here, there's a gap. All right. Now, in problem B, we're talking about age and number of pets owned. That probably will show some data that doesn't really have any specific relationship, okay, which is what this scatter plot is showing us. The points show no pattern. So here's the deal. When there's no relationship, which is what's happening here, there are also not going to be any obvious outliers, gaps, or clusters in the data either. Okay, so again, if there's no relationship, we can't identify any of those other things. All right, so hopefully that makes sense. Let's maybe take a look at this extra example and let's talk about the relationship first. See, I see these lines or what could be a line is falling, right? As x is increasing, y is going down in regards to these points. That would mean there's a negative relationship between the data, okay? Now my outlier is right here. It's that point that just doesn't belong, right? That point would be at 600, all right? And then honestly, gaps or clusters, I don't really see any obvious gaps or clusters in this data, all right? So honestly, that's it for scatter plots, okay? So what you guys are gonna do now is you're gonna go into big ideas, and today you're gonna complete a couple problems under the 9.1 practice. All right, tomorrow and Wednesday you will be given IXL benchmarks on this information. Hopefully this all made sense to you. If not, always email me or ask in the discussion thread. But otherwise, I'll talk to you guys tomorrow.